You guys can see my screen?
Yeah.
Great. Yeah, I think I don't need to introduce myself to you guys because we already did it. And I and my partner, Dr. Jonghyun Woo, and Seung-Ah Choi and Song-Min Ham, we try to understand our urban condition based on the network system analysis. Particularly, we have a theme in terms of the design production called COVID-19 sort of a new normal, urbanism with a fixed load. So this diagram is basically describe what we prepared for in this workshop. The first one, we need to understand the theory and the equation and history of behind the scene of the network system, such as accessibility and centrality, and things like that. Once we understand the theory and the equation behind the scene, we're gonna make some of exercise and experimentation within the tool called NNA tool, which is numeric network analysis tool we have been developed with Jonghyun Woo. Not only that, but also for those of you guys familiar with the Python code and other scripting language things, we can expand the tool up to more the advanced level, particularly who are interested in deploying this tool to facilitating your research or analyzing the urban context things. As an outcome, we expect not only just meaningful, let's say, image or result as a form of design, also we can think about some publication or peer review journal. Yeah, but right now I have no idea. We can see how far we can push. Based on your interest and passion and direction, we are happy to help. But I'm just mentioning what possibility we have right now. So most important thing is that the primary goal of this workshop is to understand, the network analysis. This is most important things, right? Because we are dealing with the network analysis tool. But also, we introduced NNA tool, which actually encapsulate and resolve a lot of mathematical, equation, which is a little bit complicated for, the beginner. So, but the tool actually give us, some, confined way or limited way, which is a guided way to deploy the tool in the right way to analyze, compare urban context. And then based on the people's, how people follow us, based on because individual people has different learning curve, so we also have some to customize the data and in order to take advantage of the NNA tool. So we have two lecture series, as you guys know. The first lecture is more about understanding the theory and equation and history of network analysis in urban context. So Jonghyun Woo gonna introduce the tool and give us more additional information.
Yeah, sure. Hi again, Paul. The first lecture is about general knowledge of network analysis in transportation geography field. So numeric network analysis toolbox, which we developed together with NJ and me. It is evidence-based spatial network analysis toolbox for Rhino Grasshopper. It is very useful tool for evaluate diverse scales, not only for urban scale, but also for architecture scale as well. So if you want to evaluate any kinds of networks and locations in space, you can use it. Yeah, next.
Yep, I did it.
Yeah, yeah, we might talk more details about the theories and fundamental knowledges later on our lecture series and workshop, but I will briefly talk about two major concepts. The first one is centrality, which is the most important concept in understanding the hierarchy within a network. There are four things. Each of them has a unique meaning that allow you evaluate the importance of a location within spatial network. Yes. Second concept is accessibility analysis, which reveals patterns of activities in city and connectivity in space. So you can determine which locations and distances are accessible from your origin to the destination through the shortest route. So all this analysis is all the evidence-based, so you can get the numeric data as your results. So we can use all these data results by using other statistical tool, or even we can test through very basic kind of statistic descriptions through our NNA toolbox as well.
So thank you for describe the first lecture. And the second lecture is to take a look at the graph, because the network system is basically the out of graph. Yeah. So lecture B, I'm going to talk about the discrete urban space and connectivity. So particularly how to partition and connect them. So the graph is one of the basic and very fundamental mathematical object in mathematician or computer scientist people. So graph is basically basically we're dealing with the data in a spatial environment, because we are architectural design or landscape or urbanism, urban designers. So the graph is give us a way to capture data in a space. The image on the right, so this is the once we create the sort of graphs connectivity to capture this, the data in urban context. So there's a lot of terms behind the scene. So the image on the right is the how to propagate the individual the data from the origin to destination. When you create the propagation, we actually calculate a lot of different types of the metrics, such as, let's say, the viewability or amenity or sloughness or things like that. It's fully up to us what kind of data that we wanted to process during the for the propagation things. And also, the graph has a very discrete stuff, right? So we have an individual points and then connectivity between nodes, right? But the voxel, let's say in a different ways of a pixel, because pixel is basically to one scale, like data area. If you take a look at your screen, iPhone or screen, so basically this is the pixel. If you zoom in enough, so you can see one like a little scale. So voxel is the same concept, but it has the other dimension along the z-axis in a Cartesian coordinate system, for example. So it has the other connectivity. So let's say, what if we have a different types of agent on the network system? So we can rely on individual agent in a let's say layer. So it's not like this kind of Z index, but it's more about like abstract way of a Z index. So individual agent in the graph, they are talking each other. So don't worry about it. We can learn and understand this throughout the workshop later. And also, this is the other example how we capture the spatial information and processing and visualizing, and then enact the spatial information with people. And particularly, we have 3 different types of, let's say, exercise, which you can expand it to your paper or your journal review idea, whatever. But most important thing is that we have 6-bit rule, which becomes sort of a new normal in terms of urban connectivity and layout things. So we have a different types of the technology. I mean, which is nothing special. It's more about like how we packing the circle or how we partitioning the area based on the distance or like some tolerance. So computation is the computer has a lot of it's really powerful compared to the human being, right? So using the iterative process, we can compute how people maintain the 6 feet between peoples, right? And then the interesting things on the right, in the image on the right, is that we also can deploy some agent and the agent has their own sort of behavior based on their properties. And then as time goes by, they actually, become a giant like chunk of area. So I mean, this is the there's two ways of applying this kind of agent-based system on top of network analysis tool. One is before creating the network, we can actually simulating to extract some paths, let's say possible paths to build the network system. And the second way of applying the agent-based system to network system is that once we create the network, we can actually tweak the network based on the weight. So for example, how we attract agent throughout this network, or how we expose the agent throughout the network. It's all about tune the weight of the network. So for example, the image on the left, so this is actually one of my previous, let's say, project. At that time, my goal is to create some evacuation plan, so individual people, I mean the individual flow has the loom, and the loom has their own maximum type of maximum people in individual loom. And then once the fires start, people try to try to find the shortest path. But keep in mind, we need to wait. We need to maintain the distance, right? Otherwise, we need to wait. So in this context, maybe you can find the other, let's say, detour way to evacuate, right? So I mean, this is one of the example how we deploy the agent system on top of a network system. And then the other image on the left bottom, so I create a graph. Yeah, the graph, as I said, it has a node and then the connectivity. And then once you interact with the graph, they actually interact. You can drag or you can insert by clicking on mouse on the screen. And then there's a black, let's say, paint is drawn on the background, right? So this is all about how we tracking the individual, the node in a network can interact. So for example, node 1 collide with node 5 or 10 or things like that. So we basically create the connectivity of the data flow. So we can actually tracking throughout the timeline what caused the other, let's say, the result. It's like a chain effect. So thanks to the computational power, we can explicitly tracking and then deploy and then understanding the data flow in order to understand what's going on behind the scene in the network. So anyhow, so as time goes by, they have their own optimal configuration, by the way. Also we have multiple. Yep.
We've got a question on the chat room.
Okay. Let me.
Mayu just mentioned, what's the relationship between graph 1 and graph 2? Can you please explain?
What is graph 1 and graph 2? Let me see chat.
I just wanted to clarify, in your, yeah.
Okay, so actually, this is more about the layout problem. I think, by the way, thank you for pointing out. So this, the image is more about once we populate the path, right? So now we have the path that the agent can follow, right? And then the agent can follow in order, and follow the path in order. But throughout the travel on the individual path, they need to maintain the distance between agent. Yeah, this is the point that I want to make in this slide. The second thing is there's two different constraints. One constraint is the individual node can collide each other and then push each other, but at the same time, there's the edge, right? Edge has their own length. Also, we need to maintain this length as well. So there are two different types of a goal in order to optimize the position. Yeah. Is it right answer to your question?
Yeah, I understood it. Thanks a lot for explaining.
Yeah, I mean this is more about the point out what we have been prepared. So as exercises goes on, so we can make a more a study or scenario behind the scene, and then based on you guys' purpose or interest, we can assemble or disassemble possible technology. Yeah. Okay. Yeah, and then this is the example how we deploy the agent on top of the network system. So once we found the like a optimal path, this is actually Union Square in Manhattan. And then inside of the park, we can explain or you can deploy the agent based on the rule, and then they actually create their own path, and then we can distill the path and then create a new network that we can also analyze again. So this is like a more like an iterative process. It's more about like how you design your strategy to govern the site using the networks analysis system. Okay, this is sort of our last slide. So as you can see, the letter 2 color is it's nothing special compared to the schedule in the social algorithm website. So, but I think it's let's say it's almost impossible to catch up all the workshop and lecture series within only 2 lecture series. So I discussed about this problem with other people, with Dr. Jonghyun Woo and other the Soham. And we decided to make one additional. This is actually optional things, right? So additional 1 hour every day, 1 hour, let's say, troubleshooting time. So starting from 19 to 27. So individual, every day we're gonna open a meeting starting from the 9 to push your exercise or hypothesis for your final project. And also possibly you guys can have some troubleshooting for the Python or some problem in terms of using NNA tool that we provided with you guys. So I mean, this is the, let's say, schedule within additional small chunk of workshop to you guys. That's it. Thank you. If you guys have any question, please let us know, and then we can answer you guys' question. Yeah.
Thank you very much.